Lesson 3, Properties of the Real Numbers. In this lesson, we will present the formal properties of the real numbers. Although this material is a bit abstract, understanding it thoroughly is important since it is the basis of solving problems in algebra. We will refer to these properties frequently in later lessons. The properties are closure, inverse, identity, associative, commutative, and distributive. We saw the first three properties in our previous lesson, but we will give the definition of each of them here. First, we have closure under addition and multiplication. Under addition, this means that for any real numbers x and y, their sum is also a real number. For example, if we take the x and y to be the real numbers 3 and 4, and add them, the result is 7, which is a real number. Likewise, for real numbers x and y, their product is also a real number. If we take x and y to be the real numbers 5 and 2, and multiply them, the result is 10, which is also a real number. The second property is inverses. For addition, this means that for any real number x, there exists a y such that x plus y equals 0. Of course, the additive inverse of x is negative x. If x equals negative 2, for example, the inverse is 2. For multiplication, we have that for any real number x, there exists a y such that x times y equals 1. The multiplicative inverse is the reciprocal. So if x equals 3/4, the multiplicative inverse is 4/3. The third property is identity. The statement of this property for the additive identity is that there exists a real number x such that for any real number y, x plus y equals y. For addition, our identity element is 0. So x is 0 in this case, and if y is 5, we have 0 plus 5 equals 5. Likewise, for multiplication, we say that there exists a real number x such that for any real number y, x times y equals y. The multiplicative identity element is 1. So x is 1, and if y is 8, we have 1 times 8 equals 8. Next, we have the associative property. For addition, this says that for any real numbers x, y, and z, adding x to y and then to z is the same as adding y to z and then adding x to that sum. For example, if x is 3, y is 2, and z is 8, we can add 3 and 2 to get 5, and add that to 8 to get 13. On the other hand, if we add the 2 and the 8 first to get 10, and then add 3 to that, we still get 13. For multiplication, the associative property says that for any real numbers x, y, and z, multiplying x by y and then by z is the same as multiplying y times z and x times the product. For example, if x is 3, y is 2, and z is 5, we can multiply 2 by 3 to get 6, and then multiply by 5 to get 30. On the other hand, if we multiply 2 by 5 to get 10, and then multiply by 3, we also get 30. The commutative property says that we can swap the sides of the arguments. For addition, we say that for real numbers x and y, x plus y equals y plus x. So if x equals 2 and y equals 3, we have 2 plus 3 equals 5, and 3 plus 2 is also 5. For multiplication, we say that for real numbers x and y, x times y equals y times x. So if x equals 6 and y equals 7, we have 6 times 7 equals 42. On the other hand, 7 times 6 is also 42. Lastly, we have the distributive property, which describes how addition and multiplication combine. The property shown here is the left distributive property, which says that for real numbers x, y, and z, x times the quantity y plus z equals x times y plus x times z. For example, if we take x to be 2, y to be 3, and z to be 5, then for the left side we take 3 plus 5 to get 8, and then multiply by 2 to get 16. For the right side we take 2 times 3 to get 6, and 2 times 5 to get 10, and then add them to get 16 again. Like the left distributive property, there's a right distributive property, which can be derived from left distributive property and the other properties. Beginning with x plus y and then multiplying by z, we want to show that this is equal to x times z added to y times z. To do this, we begin with the left side of the equation. Then we swap the multiplied terms by the commutative property of multiplication. Then we use the left distributive property to distribute. Finally, we apply the commutative property of multiplication again to get our result. This proves the right distributive property. This concludes the lesson.